Do you ever look up at the night sky and wonder if there's intelligent life out there? Maybe little green men on Mars or aliens zipping around in UFOs? I do pretty much every night.
Look, I do too. And it turns out there could even be aliens in our own solar system, but not like the ones that we're picturing when we think of intelligent life out there in the universe.
Right. So did you see that story on Pluto?
Yeah, that's exactly what I meant. We once thought Pluto was just this frozen ice world, but it turns out it might have oceans under its surface. And we know on Earth that oceans are a great place for life to thrive.
Especially some of the most interesting and unique forms of life.
Absolutely.
Come from these environments where you wouldn't necessarily think they exist.
Yeah.
So I think this is so cool. So what about Pluto makes us think that there's an ice water underneath it? What results were there?
That's also a good point, because we didn't just, cruise over it and see waves breaking under the surface. All of this information came from the New Horizons spacecraft, which flew by Pluto over 2 years ago, and we're just now collecting all that data and turning it into results. And so what New Horizons actually saw was ammonia on the surface. And so the idea is
You're excited?
Yeah, ammonia. But the idea is, how do you get ammonia on the surface? And it turns out ammonia is fragile, and it can get broken apart by radiation and space, other elements in space, over thousands and millions of years, which to us seems like a really long time, but cosmically speaking is quite short.
It's just like almost a blink of an eye.
Yeah.
And so we think we see ammonia on the surface of Pluto, not because it's been there for millions and billions of years in the formation of the solar system, but because it's been replenished from coming up from these cryovolcanoes that live under the surface in a probable subsurface ocean, which is really exciting. But more on that later.
Yeah, so we'll go into the full details of exactly why these results are so interesting to us and how they could potentially lead to clues of life. But we wanted to first, come back and give a little introduction about the blast off. So our first episode was really kind of this knee-jerk reaction to an announcement, and
we were a little upsetty.
We were a little
about the
upset.
satellites.
Yeah. And so we thought, well, that's good inspiration, because we're always hearing about these, headlines in the news. And so we thought you all might appreciate the opinion of some astronomers. So thus, the blast off will continue, and each week we'll try to explore some of these, subjects in the news, but we also want to tell you a little bit about what we study and what inspired us to be astronomers. So, without further ado, I'll introduce myself again. I'm Dr. Rebecca Allen, and this is future
Dr. Sarah Webb.
And this is the blast off.
And so we started our search for life in our two neighbouring sister planets. So we've got Venus and Mars. And all of these planets, Venus, Earth and Mars, sit in this region called the habitable zone, which means at one point or another they had liquid water on them, which is a pretty key element for life. However, they might not be the perfect place for life at the moment. So Venus, she's a bit of a mess.
Hot mess.
Hot mess, literally. She's got runaway greenhouse gas emissions. She's rotating very slowly because she's got a weird tidally locked
That's right. It's
orbit.
So close to the sun. It's really like the Goldilocks and the Three Bears. So Venus is a little bit too close.
She's too hot. Then Earth, just right. But then we also have Mars, which is just a little bit too cold. Yeah. Also, we thought until recent results just a couple of years ago that there might still be liquid water under the ice poles.
That's right.
Which is really interesting. And so we started looking at these planets first for life. And Venus proved insanely difficult because she's got an insane amount of pressure. So insane amount of pressure and heat. So any probe sent down didn't last very long. And Mars was the next choice because it's easier to rover around.
That's right.
The rovers don't die so easily. And it's probably a better place for any candidate life.
That's right. And it has to do with, it's really interesting to me. I study galaxies, so I look at stuff that's really far away. Venus is actually closer to Earth than Mars is to Earth. So the idea that we're sending everything to Mars isn't, actually the first thing that you would think.
No.
But Mars, even though it's much smaller than Venus and Earth, probably was at a point early in the solar system's history where it could have hosted life even before Earth and certainly Venus. And Venus, we're bagging it for sure, but what's cool is the unique conditions that it exists in could actually mean it could have these microbial life in the atmosphere. And we might explore that at some point in the future. But let's get back to what we're doing on Mars to look for life and to really dig into these clues that we have found already, just using robots now. That's pretty awesome to tell us that there could be this microbial life still there, or certainly probably was at some point in the past.
That's right. So we've sent a ton of different probes to Mars, some that are stationary, some that are moved. You're probably all very familiar with Curiosity's adventure.
Yeah.
And these probes are literally scratching the surface and trying to see what they dig up. Are they finding different types of amino acids? Are they finding anything organic? And the one problem with these are it's very limited in what it can do. And
That's
so
right.
this gets to the whole, well, if we want to find life, maybe we should go to Mars.
That's right. It's hard to send stuff into space. Mars is far away, and so every little piece of these missions has to be, carefully crafted for years, and it's, expensive money and time wise. And so these robots that are there, they are extremely sophisticated, but they're still quite simple in their functions. And so where human scientists can do things in real time, analyze sample, use different instruments to understand what materials that sample is made out of, our little robots just aren't there. And even furthermore, what Sarah was just saying is that the best place to look for these clues for life probably isn't right on the top of the surface where it's been blasted by radiation from the sun, but is deep down. Now, there's a lander on Mars now, which is actually capable of drilling down a few meters, and I can't wait to see those results, what comes back, to really tell us what's going on under the surface. But the reality is there was two new missions mentioned, and one was a team up of the European Space Agency and NASA, and the whole idea is to create this, very complicated mission, multi-stage mission where we get samples brought back to us from Mars.
That will allow us to do so many more things.
Absolutely.
But even before we get the sample brought back, we have so many enticing clues that there might be some goodies there, which is very exciting. And so what would life look like on Mars? Is it little green men running under the surface?
No. It's going to be some funky microbes, like what we see in underwater vents on Earth or near geysers, things which have really, in our idea of how life would exist, they have no business existing, but yet they do. Life is persistent, and that's why we keep sending stuff back to Mars. But I wanted to touch on the fact, to me, a very interesting thing about these announcements and the idea of a sample return mission. We're supposed to try to do the sample return mission in the same time span that we're meant to actually be sending people to Mars. So that to me makes it doesn't look good for sending people to Mars. I think our priority is still going to be these sample return missions, because how can you spend the time and resources on both of these missions? What do you think, Sarah?
I think that's really interesting. So I've got the opinion, purely an opinion, that even though going to Mars as a human would be incredible, the amount of money that is needed to send a person to Mars, especially because of the once you're out of the radiation belt off on your way to Mars, the spacecraft we need to have is so complex, so expensive. You could get a dozen or so different types of rovers, probes, all sorts of things that could be doing science. And so my opinion is of sending the machines to do the work for us, at least in the meantime. I still want to see man get to Mars, but I think we can get results without it, which is quite exciting.
Well, and what we've seen is that, our closest neighbors might not be the most interesting places
Not at
to
all.
look for these weird different types of life. And why look at planets at all
when you can look at moons?
That's right.
So Saturn and Jupiter are the next planets along in the line, as you probably know. They are the big beautiful gas giants, and them themselves are very pretty and lovely, but you're probably not going to find life in them. But their moons that are orbiting might just have the perfect conditions to find the weirdest, funkiest, maybe not even carbon-based life forms.
So let's start with Saturn. The Cassini mission taught us so much about not just what a gas giant planet is, how its ring structures work, how little moons can be born inside its ring structure. And that whole thing might be a great analogy for our own early solar system.
Right.
No, that's not even the juiciest bit. When Cassini was running out of fuel and it was time to say goodbye, instead of letting it drift off and collide into whatever moon or wherever it might go, we were so worried about potential contamination that we actually told it to crash itself into Saturn. Why was that, Sarah?
Well, the reason was, so because this mission wasn't a planted mission, so it wasn't landing on a moon or on a surface, the amount of sterilization was much less than something we were, like the Curiosity rover we'd be sending to Mars. So it was sterilized, but it very well could have had Earth bacteria, Earth single-celled organisms, all sorts of contaminants. And we've seen from the International Space Station that when you put them on the outside in the freezingness of space, they live.
Yeah.
They live, and sometimes they thrive depending on what the thing is. And so
life persists. Life
it does
persists.
And there's a really real possibility that Cassini had that on it. And because we saw all of this tantalizing evidence that there are oceans under the moons, that there's geysers, there's volcanic activity, if we had have let it crash onto there, we would never ever get a consistent answer if we gave it life by accident or if life already existed. So I think it's the best thing we did for science.
I agree. So let's just quickly go through some of these awesome moons because they deserve a little bit of recognition.
They do.
So when we're talking about these subsurface oceans, the first one that comes to mind is the moon Enceladus. It is just as hard to say as you think it is. And again, it's one of these ones where it's like, oh, it's a little frozen, icy moon. No, Cassini took pictures and we can actually see jets of water going hundreds of meters out into space. That means stuff is happening under the surface. And then we go over to, of course, the wonderful Titan and the probe that Cassini sent down and took pictures of the beautiful lakes of methane. And so the idea is that these little moons could be the best worlds to find life. But how do you get an ice moon way out in the solar system and a little planet with methane lakes? How is that even possible?
So something cool is happening there because of the mass of these gas giants, the mass of our sun, and the way it all spins around our solar system. We end up getting these tidal forces acting on these moons. And so layers, like hundreds of meters down under their surface where there is liquid, either water or methane lakes on the surface. So we'll use Enceladus for an example.
Yeah.
So we think it has liquid water, not your normal Mount Franklin water, but
super salty.
Super salty.
Like how we felt after the satellite launching announcement and the Starlink announcement, that kind of salty.
Super salty. So it's got this really salty water that's, deep under the crust, but when it's orbiting around Saturn and orbiting around our sun, the tidal forces can stretch and pull the crust of that planet and create these little crater dips and jigs and what are they
all
called?
kinds of heat. It's able to generate heat
and pull it apart, and so it's able to spew up through these little gaps, and
That's
because
right.
it's hot enough, it's able to vaporize, and that's why we see these beautiful plumes coming out of it.
So amazing physical processes going on, and it's not even one of the main planets. But we do have to go back and talk a little bit about our favorite, one and only dwarf planet, Pluto. So like we said in the beginning, we for a long time just thought Pluto was this weirdo last planet in our solar system, icy, nothing exciting going on. And when New Horizons first flew by and we got those first pictures, we saw that the colors were interesting. It had this reddish hue, but there was evidence for what we call reshaping. So the surface wasn't just staying static. Things were going on. And so that could be in part due to this idea of tidal forces. Maybe something's tugging
And it is on
Pluto.
a weirder orbit.
Yeah.
The reason it's not a planet anymore, RIP, is because it is on such a weird inclination compared to the rest of the planetary disk. And that might be adding to the way the rock is actually moving and forming.
Sure.
Because of its orbit around the sun, which is really interesting.
Yeah. But so this could be the subsurface ocean underneath Pluto. And again, how do you get water way out there? Well, Well, part of what ammonia is able to do is it's a common ingredient in antifreeze. So it lowers the temperature, the freezing temperature of water. So it has to be super, 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 super cold to freeze. And so that might be part of it. It's this weird saline ammonia mixture that just doesn't freeze. And it could also be due to tidal forces. But the reality is that it's not frozen solid. And so shielded from the radiation of our solar system, underneath that surface in this sludge, there could be this microbial life. And so I can't wait to send more missions out to the outer solar system. And part of that is because those bodies that are in the outer solar system might have been just as important for seeding life on Earth as anything else.
Are you talking about panspermia?
I am talking about panspermia. I'm talking about comets and asteroids and the littlest bodies in our solar system, which we have found the building blocks to DNA on.
Right. They literally land here from hundreds of thousands of kilometers in the outer Kepler belt.
Yeah.
End up landing
Don't
here.
worry, nobody can say it. It's Kuiper belt and Oort cloud.
Oort cloud.
Who gets to name these things, really?
But anyway, they land on Earth. And when we analyze them, we're so surprised to find that the amino acids that we need to start building up our DNA and our RNA, they exist on these comets, which is so exciting because it means that Earth might not have been just right for life. It might have just been a boring old rock. And then all of a sudden it got seeded by more and more of these amino acids coming in from these comets. And all of a sudden maybe the conditions were right
We're just
for
right.
life.
Yeah.
Which is pretty damn exciting.
So it's this wonderful, complicated system that is our solar system. And, you know, we talk about comets and asteroids dumping all these beautiful ingredients on Earth. We might have even gotten most of our water from asteroids. But it turns out that Earth is pretty good at giving back too, thanks to the simulation. Right, Sarah?
So cool. So we've all heard of dinosaurs and we know they died.
R.I.P. again.
Now the reason they died is because of this giant asteroid that hit into the coast of Mexico.
Yeah.
It left a crater that's, almost 100 kilometers across, this massive impact. And what happens when you have a massive impact is things bounce back. Newton's laws of motion.
Yeah.
And so this simulation took the Earth's mantle, so it simulated the Earth's mantle and simulated this rock smashing into it. And it wanted to see what type of debris were we sending out into the outer solar system. And it found that not only were we sending massive chunks of debris to Mars and probably Venus, but we were sending particles as far as Jupiter and Europa. So we might have shared our key for life to the rest of the solar system.
It's really one messy mystery. And if we do find microbial life on Enceladus, poor Cassini might have crashed for nothing because those ingredients could have been brought there back when the dinosaurs bit the dust. And so, honestly, there's so much more that we could talk about for life, but the reality is, where are we in their solar system? We've gotten a lot of clues, no concrete answers, and certainly no little green men yet. Yet. But that brings me to my next point. So to really continue looking for those little green men, or maybe even there's Earth analogs, we now have to go beyond our solar system. And in next week's episode of The Blast Off, we'll touch on some more breaking news stories, but we're also going to go into a bit of how we found planets outside of our solar system. Not a trivial thing, it turns out. So thanks so much for joining us this time. This has been
The Blast Off.
Thanks, guys.